just some, quick examples of the application of these, structures and knowing the structures and all that in the oil and gas industry, in the especially in unconventional reservoirs studies. Okay, so moving forward, we are going to divide these hydrocarbons in different homologous series. Okay, as I said, the homologous series are series of molecules with similar structure and graded physical and chemical properties, meaning that these are graded, meaning that we can infer them. They have a correlation with the weight or the number of molecules. Okay, so similar structure, graded physical and chemical properties. Okay, so how do we do that? Generally, we are dividing the hydrocarbon components into two major groups. These are aliphatics and aromatics. Okay, and then the aliphatics, we are going to divide them in four groups, which are alkanes, alkenes, alkynes, and cyclic aliphatics. Okay, so generally, this is one of the closed book questions for the midterm exam. And every time I either ask you to name different homologous series of the hydrocarbons, which are aliphatics, aromatics, and the aliphatics are divided to alkanes, alkenes, alkynes, and cyclic aliphatics. Or I'll give you this structure and I'll ask you to fill up the spaces with the names of different homologous series. Okay? So we start with the aliphatics, and in the aliphatics we start with the alkanes, and then we will cover the rest of the components. Okay. So what are the alkanes? Alkanes, as I said, these are saturated hydrocarbons. Okay. The general formula for alkanes is CnH2n plus 2, which means for any number of carbons, you have 2n plus 2 number of hydrogens. So if C is 1, the hydrogen is 4. If C is 2, the hydrogen is 6. Okay, so for every number of carbons, you have 2n plus 2 number of hydrogens. Okay, so C1, and if n is equal to 1, it becomes 2 times 1 becomes 2 plus 2, 4. So it becomes CH4, that's our methane. If the number of carbons are 2, then 2 times 2, 4 plus 2, 6. So it becomes C2H6, which is ethane. If it becomes 3, I have propane, which becomes C3H8. 3 times 2, 6 plus 2, 8. So 1, 2, 3, 4, 5, 6, 7, and 8. Hydrogen and 3 carbons. Okay. So we need to memorize the formula for alkanes. Alkanes, the name of all the alkane groups will end up with A and E. Okay. At the end should have A and E, like methane, A and E, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane, it goes on and on. Okay, so if I see the name of the structure which ends with A and E, I know that belongs to alkanes. And I know the general formula of that component is CnH2n plus 2. And I know since this is saturated hydrocarbon, there should be all single bonds. And their structures, I don't see any double bonds or triple bonds. So these are all single bonds. Okay, so alkanes group or alkane homologous series are made of components which are all single bonded. Okay, and their name ends up with A and E, and their general formula is CnH2n plus 2. Okay, these are some representation of that, like methane, all single bonds, you have 1 carbon. Ethane, you have 2 carbons, again, all single bonds. So if I have 2 carbons, I should have 6 hydrogens. So 1, 2, 3, 4, 5, 6. Then hexane. It's very important to know that it's not like always we have these straight chains, okay, the straight chain molecules. Sometimes we might have some branches, okay. So the branches might show up in different parts. So again, like here, I see all these bondings, these are all single bonds. So I know this has to become an alkane group. So this structure name should end up with A and E. Okay, and we'll learn. This is basically I have six carbons, so it's hexane, and since it has an isomer, that it has some branches, we call it isohexane. But this is not the conventional naming, so I'll show you. I'll discuss how to name this structure. Actually, this structure is called uh, 3-methyl propane, 3-methyl pentane. Okay, and how do we know that? Because in the nomenclature, as we will discuss that, we will look at the longest straight chain. The longest straight chain has 5 carbons, so we call this pentane. And it has 1 methyl group in the third carbon, so we call it 3-methyl pentane. Okay, we'll go over that. But this structure, even though it has branch, it belongs to alkane. But this is a different structure, even though it has all single bonds, okay, but it's in the cyclic form, okay. We call that cyclohexane. This belongs to a different homologous series because we will see that this structure will have a different properties than these structures. So since the whole idea of putting these components in the homologous series was to be able to infer their physical and chemical properties, if a component doesn't follow that trend, then we have to put it in a different, group. So that's why this cyclic structure is not in the alkanes group. As I said, the alkanes could be a straight chain or they could have some branches, okay, like straight chain butane or 2-methyl propane, okay, which is basically butane with the branch, okay. So these are other examples of the alkane. So I look at this structure, they're all single bonds. So I know this belongs to the alkane. Whatever that name is, it should end up with A and E, okay? Here again, all single bonds. So I know that belongs to alkane. Whatever the name is should end up with A and E. And I know their general formula should be CnH2n plus 2. The same here, all single bonds belongs to alkane and the name ends with A and E, okay? As I said, sometimes in our class, you are welcome to show the structure in this form or in this form. As I said, it's easier to just not show the hydrogens because we know the hydrogen has a 1 bonding, so there's no other way. But the rest, we need to show them. Like carbon has 4 bondings, so it has 3 with hydrogen, but we should show the next one with the other carbon, okay? So how do we name these structures? We are going to follow the IUPAC nomenclatures, okay? So this is a very straight way of naming these components. And the way it works is, first I'm gonna look at the structure, okay? Like here, I'm looking at this structure. They're all single bonds. So I know this belongs to the alkane. So whatever the name for this structure is, it should end with A and E, okay? Since they're all single bonds. I don't see any double bond here. They're all single. So the name, whatever that is, should end up with A and E. That's the first step. The second step is to identify the longest straight chain. So I'm going to find the longest straight chain, like which chain gives me the largest number of carbons. So if I start from here, 1, 2, 3, 4. So this chain has 4. So 1, 2, 3, 4, 5. So this has more. So this is the longest chain. And 1, 2, 3, 4, 5. So either this way or this way, I have 5 carbons in a longest chain. Okay. So that basically defines my structure. So if I have 5 carbons, then I have pentane. Remember, if I have 1 carbon, it's methane. 2 carbons, it's ethane. 3 carbons, propane. 4 carbons, butane. 5 carbons, pentane. So the longest chain has 5 carbons. So the name becomes pentane. Now I need to number the carbons. I number them from the end, which is closest to the branch. Okay. If I number them from here, then it becomes 1, 2, 3. So the closest, so the first branch gets the number of 3. But if I start from here, it becomes 1, 2. So this way, this end is closest to the branch. So I'm going to number them from that side. I number them from the side which is closest to the branch. So it becomes 1, 2, 3, 4, 5. Okay. Now I need to mention these branches. Okay. So if I have a methane, CH4, appears as a branch, then the name becomes methyl. If I have ethane, like C2, as a branch, then it becomes ethyl. If I have a propane as a branch, it becomes propyl, and butyl, pentyl, hexyl, and it goes on and on. So I have a methyl group sitting on the second carbon and methyl group sitting on the third carbon. So I mention where those branches are. I have a branches in the second and third, and since both of them are methyl, I call them dimethyl. So the name is 2,3-dimethyl pentane. Okay. So some more examples. So this one, as I said, it's again all single bond. The name ends with A and E. I have 5 in the longest chain, has 5 carbons, so it's pentane. And I have methyl group in the second and third carbon, so I have 2,3-dimethyl pentane. This is not 3,4-dimethyl pentane. We number the carbons from the end, which gives me the smallest number for the branches. Okay, and this structure again, all single bond. So the name ends with A and E. I need to find the longest chain. So 1, 2, 3, 4. So this is the longest chain. It's not always the straight chain is the longest chain. It might go up. Okay, you just need to count the number. So or here 1, 2, 3, 4. It could be this again. The longest chain has a 4 carbon. So all single bond. The name ends with A and E. It has 4 carbons. So it's butane. Then I need to number the carbons. I number them from the end closest to the branch. So from here it becomes 1, 2. From here it becomes 1, 2. But I name them from the end which is closest to the more complex branch. Here I have 2 branches, so it's more complex than this one. So I number them from here. So 1, 2, 3, 4. And then I need to say what are these branches. So this is CH3, CH3, CH3. So these are all methyl groups. So I have 2 methyl group on the second carbon and 1 in the third carbon. So it becomes 2, 2, 3 trimethyl butane, since I have 3 of them. Okay. If I have 2 of them, it becomes dimethyl. If I have 3 of them, it becomes trimethyl. So 2, 2, 3 trimethyl butane. Okay. So I look at the structure. If it's all single bond, it belongs to alkane. The name ends with A and E. Then I need to find the longest chain that defines the actual name of these structures, which is butane. Then I need to number the carbons. I number them from the end, which is closest to the branch. If they're the same, then from the end, which is closest to the more complex branch. Okay, so here this end is closest to the more complex branch than this end. Okay, so I number them from here. Okay, more examples. So as I said, this could be more complicated. Okay, like here again, but the rule is very simple. I look at the structure, all single bonds. I don't see any double bonds, so the name has to end up with A and E. I will identify the longest chain. So here I have 10 carbons in the longest chain, so it's decane. I need to number them from the end closest to the branch, so it should be from the right. So 1, 2, 3, 4, 5. And then in the 5th carbon, I have a structure which also has a branch. So again, if this becomes, so this is the first carbon, and then in the main carbon I have 3. So, and then in the first one I have a branch. So I have one branch of methyl on my propyl, since this is 3 in the main branch. So it's a propyl with 1 methyl group. So it becomes 5, 1 methyl propyl decane. Okay, so we'll continue on more examples in the next